proof. In this video we'll be looking at algebraic proof, but before we start we need to lay the groundwork for some basics. We need to show how to define the following. So an even number we can define as 2n. An odd number is always one greater than an even, so that could be 2n plus 1. Three consecutive numbers could be n, one bigger, n plus 1, one bigger, n plus 2. Three consecutive even numbers. Well, our first even number would be 2n. If we just added 1, that would be an odd number. So the next even would be 2n plus 2. And the next even would be 2n plus 4. Three consecutive odd numbers. Well, the first one is 2n plus 1. To get the next odd number we need to add 2. So it would be 2n plus 3. Adding another 2, so the next one would be 2n plus 5. Two even numbers. Well, we've already got an even number 2n. We're not told that they are consecutive, so the next even number or another even number might be 2m, where m is an integer. And similarly with two odd numbers, the first one 2n plus 1 and another odd number, not necessarily consecutive, would be 2m plus 1. The simplest sort of question you could be asked is the following. 2/3 is equivalent to 1/2 plus 1/6. In this sort of question you've got to be careful. You take the more complicated side, in this case the right hand side, and prove it is like the left hand side. So therefore 1/2 is equal to 3/6. Therefore 3/6 plus 1/6 is equal to 4/6, but 4/6 is equal to 2/3. Therefore left hand side is equivalent to right hand side. Always make sure you complete the last statement if necessary. Another sort of question you might get. Prove the sum of three consecutive even integers is divisible by 6. Right, let's start by writing down our three consecutive even integers. Well, they would be 2n, 2n plus 2, and 2n plus 4. We want the sum, so we add them together. Therefore, we got 2n plus 2n plus 2 plus 2n plus 4, which is equal to, so therefore we've got 6n plus 6. Right, we need to prove that that is divisible by 6. If a number is divisible by 6, it appears in the 6 times table. Therefore, if we factorise, take 6 out, we get 6n plus 1. Therefore, 6 times a number is divisible by 6 in 6 times table. Another question, prove that x plus 2 over x minus 1 over x plus 1 equals 2 times 2x plus 1 divided by x times x plus 1. In this question, we will take the left-hand side, bring it together, and hopefully it will equal the right-hand side. The first thing we need to do is to get both fractions over the same denominator. If I multiply the top and bottom of the first fraction by x plus 1, I get x plus 1 times x plus 2 all over x times x plus 1 minus, then multiply the second fraction top and bottom by x minus 1 all over x times x plus 1. Bring the two fractions together and multiply out, so I get x squared plus 2x plus x minus 2. Be careful now with the signs. Minus x squared plus x all over x times x plus 1. Tidy up the top, I get 4x plus 2 all over x times x plus 1. Factor out the 2 on the top, I get 2 lots of 2x plus 1 all over x plus 1. Therefore, the left-hand side equals the right-hand side. Proof. And the final one, prove that x minus 3 over x minus x minus 2 over x plus 2 is equivalent to x minus 6 all over x times x plus 2. Take the left-hand side, manipulate it, and prove that it is equivalent to the right-hand side. So therefore, multiply the first fraction top and bottom by x plus 2. So you get x plus 2 times x minus 3 all over x plus 2 minus, multiply the top and bottom of the second fraction by x times x minus 2 all over x times x plus 2. Multiply out, so we get x squared plus 2x minus 3x minus 6. Be careful with the sign, so minus x squared plus 2x all over x plus 2. Straighten out the top and you get x minus 6 all over x plus 2. Therefore, left-hand side is equivalent to right-hand side. Proved.